example right here. So they measured the height in inches of boys who are X month of age. And they came up with this function that fits the data. So they plotted the points, and the closest they could come up with was 2.9 times the square root of x plus 20.1. Can anyone explain what this is? What is the base function? Square root of x. What is the first transformation on the square root of x? No. No. In order of operations. We have to multiply by 2.9. So what type of transformation is when we multiply by 2.9? Vertical stretching. Very good. Vertical stretching. And then by a factor of 2.9, and then up 20.1. Exactly. Great job. Okay, so we already described. It says describe how the graph can be obtained from the transformations, blah, blah, blah. According to the model, what is the median height of boys who are 48 months old, according to the graph? Or 4 years old. So 48, 50, I would say about 40 inches. Okay. Use a calculator and round to the nearest tenth of an inch. The actual median height for boys at 48 months is 40.8 inches. How well does the model describe the actual height? So we have to put this function in the graphing calculator. Let's do that. I'm ready with that. Yes, any questions? Any questions? In y equals 2.9 times the square root of x, and then plus, what was it, plus 20.1, correct? Yes. Okay, so second and table. Oh yeah, I'm sorry, it always goes back to. Okay, so we want to plug in 48 months. So the model gives us 40.16. They say that the actual average height is 40.8. And now we're asked, how well does the model describe the actual height? I can't say it anymore. I said it already. So how well does it describe? Pretty good. I would say so. Yes, pretty good. Use the model to find the average rate of change in inches per month between birth and 10 months. You had a similar problem on this test. So the function is 2.9 the square root of x plus 20.1. And they're asking us to find the average rate of change between birth and 10 months. Between 0 and 10 months. How do I find the average rate of change between 0 and 10 months? How did we find the average rate of change on the test? So f, the average of the function between 0 and 10, was f of 10 minus f of very good, over 10 minus 0. Perfect. So let's find those numbers at the top. I know it's f of 0 must be 20.1. The denominator is 10. In the graphing calculator, I will plug in 10 and see what I get. I got 29.271. So 29.271 minus 20.1 is 9.171 divided by 10, which is approximately 0.92 inches. It's a rate of change per month. So the average rate of change per month, what would you say? These boys grow at a rate of approximately 1 inch per month, approximately, between 0 and 10 months. I don't know what happens otherwise. But between 0 and 10, they appear to be growing at a rate of 1 inch per month. Would you agree? Final question. Use the model to find the average rate of change in inches per month between 50 and 60 months. So now they want the average rate for this function between 50 and 60. Okay, f of 60 minus f of 50 divided by 60 minus 50, which is 10. But I have to determine with the calculator the other two numbers. So I plug in 50, and I plug in 60. So 42.56 and minus 40.61 divided by 10. So what do I get here? Is it's 5, it's 9, and 1. Right? So 1.95 divided by 10. So approximately 0.2 inches per month. Oops, sorry. So approximately 0.2. Now here's the question. How do you see this difference on the graph? Does it make sense or not? So look at the, I don't have a pencil, so I don't want to write on the book, but between 0 and 10, do you see how steep the line is that we determine the slope for? But look at between 50 and 60. So this is the slope of 0.2, and this is the slope of 1. So between 0 months old and 10 months old, these babies grow at a rate of almost 1 inch per month. And between the ages of 50 months and 60 months, they grow at a rate of 0.2 inches per month. Okay, so let me just give you some heads up. We completed 2.5, so you can finish 2.5 in my math lab, and I have 3 more minutes. You have to wait. And 2.6 and 2.7 are talking more about combinations of functions and function composition, adding, subtracting, multiplying, and function composition. 2.7 inverse functions, and 2.8 the distance formulas. So this was a little bit, it took us a little bit longer.